Welcome to the next lecture in Theory of Computation, and in this lecture we will be seeing an example about our DFA or deterministic finite automata. We shall be seeing how to design a particular DFA in this example. Alright, so let's get started. Okay, so we have an example here in which the language L1, which is the set of all strings that start with 0. L1 is the language that is the set of all strings that start with 0, and we need to design a deterministic finite automata or DFA for this language L1. But before starting that, let's see what will be the elements in this set. Now, this is a set of all strings that starts with 0. The elements in this would be like 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 0, 0, and so on. This is actually the final set because every string that starts with 0 is mentioned in language L1. So let's see how we can design the DFA for this. So whenever we start a DFA, we should always start with a state, which is my initial state or start state. So I already told in the previous lecture that whenever you see an arrow coming from nowhere pointing to a state, that shows that that is the starting state. So A is my starting state. So I'm starting with A. If I get input 0 in A, what will happen? And if I get input 1 in A, what will happen? Let's see what should we do. Suppose I get input 0 in this A, I send it to another state which I call B, and I put a double circle around this B. Now what is the meaning of this double circle? Double circle means this is the final state. Now when I give input 0 to A, it goes to B. Now that is because I have to design a DFA that accepts all strings that start with 0. So A is my starting state and I'm getting input 0. That means 0 is the first digit. Then it goes to B, which is the final state. And whenever a string reaches the final state, that means that the string is accepted. And whenever the string does not reach the final state, that means it is rejected. So whenever I'm starting with 0, it should reach the final state because it should be accepted. Why? Because I have to design a DFA for all strings that start with 0. Now I'm in state B. And state B, after reaching state B, in B also I can either get input 0 or 1. So what will happen if I get 0 or 1? Since this is the final state, I'll give a self loop here and I'll write 0 or 1. So what this means? This means that after reaching the final state B, what are the inputs you get after that, whether it was 0 or 1? It stays in the final state B itself. Okay? Because the string started from 0 and our only condition is to start that with 0. And after it reached the final state, we have here 0 or 1. It doesn't matter, it stays in the final state and that should be accepted. Okay, I hope it was clear. And now is that complete? No, it's not complete. Why? Because we only mentioned that what will happen if A gets the input 0, but we did not mention what will happen if A gets the input 1. So A is my starting state. And if I get input 1, that means 1 is the first digit. And should that be accepted or not? No, it should not be accepted. I should accept only all those strings that start with 0. So if it starts with 1, 1, what happened? I'll send it to another state which I call state C. Okay? I send it to another state called state C. Then the input is 1. When the input is 1, it goes to state C, and in state C, after reaching the state C, what are inputs I get in state C? It stays in state C itself, whether it is 0 or 1. Okay, so if a string starts with 1, it goes to state C. And after reaching state C, whether it is 0 or 1, it stays in state C. And it cannot go back to this final state anymore. Okay, so this is kind of state is known as that state, or it is also known as trap state. Why is it known as dead state or trap state? Because once you reach here, it is trapped here, you cannot reach the final state anymore, which is B. Okay, and when a string cannot reach its final state, that string will be rejected. Okay, so now my DFA is complete. Because I already mentioned in A, if I get 0, it goes to B, and if I get 1, it goes to C. It complete. Then in B, if I get 0 or 1, it stays in self, and C, if I get 0 or 1, it stays itself. Now my DFA is complete. I designed the DFA for the set of all strings that start with 0.